we have what is a Lewis structure for C2Cl4. Okay, so for this, once again, we're going to make sure we go over our periodic table. So carbon is on the 14th column. That is 4 valence electrons, but there's 2 of them. So we have 8 electrons it can use from carbon. And chlorine is on the 17th column. So that's 7 valence electrons times 4. So we have 7 times 4. It should be 28. We just double check. 28, perfect. So 28 electrons from chlorine. Add them together, 8 plus 28. We have now 36 electrons we would need to be able to solve this structure. So because carbon has the greatest number of unpaired electrons, that's what we're going to put in the middle. So 2 carbons would sit next to each other, bonded by 1 bond, and then we're going to add the chlorine. So we have 4 chlorines. 1, 2, just redraw this actually. 1, 2, 3, 4. All right, and there will be a reason why I drew it like that, and I'll show you very soon. So chlorine, we're going to start there. Right now, it's sharing 1 of its 7, so it's going to fill out the rest of the octet. 2, 3, 4, 5, 6, 7. Same thing with this one. Same thing with this 3rd chlorine, and same with the last chlorine. All right. Now the carbons, on the other hand, are sharing, each of them are sharing 3 of its 4 electrons based on the 3 bonds it currently has. So there'll be 1 unpaired here and 1 unpaired there. The reason why I drew it like this is because in order to satisfy those unpaired electrons, they're actually going to come here and form another bond with this bond. So that's going to be a double bond being formed in the middle. So if we were to redraw this, we would have carbon double bonded with the other carbon, and now we can just put it like that. Or even more specifically, like this. And that's actually, as you can see, what they have in the picture here to the left of me. And this right here will be a Lewis structure for C2Cl4. You can actually check its formal charges. Carbon's net formal charge 0 is just 4 bonds, 0 lone pairs. And that's actually what we have for both carbons. As you can see, the double bond counts as 2 bonds. So you can say, yes, it has 4 bonds and 0 lone pairs. The chlorine, on the other hand, likes to have 3 lone pairs and 1 bond, which is what each chlorine is doing. And that is why it has a formal charge of 0 as well. So this would be the final Lewis structure for C2Cl4. And if you count the electrons, we should have 36, but just to double check, in total we have 1, 2, 3, 4, 5, 6 bonds. That's 12 electrons right there. And each chlorine on the outside is having 6 electrons. So that's 12 plus 6 times 4. So that's 12 plus 6 times 4, well, it should be 24. And we do indeed get 36 electrons. So this is perfect. Okay, now let's move on to question number 8.